Okay, so I'm sure you're wondering what the heck I'm doing right now.
Made a little test rig to hang weight off of the disc.
I'm trying to show how much torque one of these discs can actually hold and sustain before it deforms and or would tear or break or explode, as everyone likes to say. What you see what I'm doing with my hands here is I'm just trying to simulate like the disc being taut if it was spinning at high speeds, so that its own straight rigidity from being spun or being held taut will keep it straight. And this valve that I'm holding off of here is about
In hands.
comes out to be 0.9 pounds. A normal disc will actually work in a Tesla turbine is it'll have all the other discs stacked up with it and rigid end plates that'll hold them all together, and the spacers and everything keep them from being able to actually flex or warp or misalign. Keeping it taut here shows how the whole disc will actually maintain a torque without warping. Even though the disc is floppy as can be, when it's kept taut, it goes really straight. And even furthermore, when there's other discs around that stop and move anywhere, it doesn't warp. So 0.9 pounds hung at a distance of 5 inches gives a torque of 0.375 foot-pounds. That's pretty significant, and this could hold much more than that. And now, when we're talking about the Tesla turbine, and if it's going to produce it, that torque that is produced by this disc will come from being spread all the way around the entire active surface area of each disc. To put things into perspective, a 100 horsepower engine spinning at 5,252 RPM would need to put out 100 foot-pounds of torque. That's a lot of torque, and one disc like this could never handle it. But in my turbine over here, I've got 75 discs inside of it. So with 75 discs, that 100 foot-pounds of torque is spread across each disc. So that comes down to only 1.33 foot-pounds of torque per disc. That's to put out 100 foot-pounds of torque with only a 75 disc turbine, and that turbine should be able to go up to 250 discs. And right now you're seeing, I've already tested this. You may or may not be able to see the creases that have already formed from this, because I've hung this big old guy here. The disc itself, if it had rigidity with the rest of the discs around it, it would have no problem carrying this weight. This is 4 pounds. To do that at 5 inches is 1.66 foot-pounds of torque on just one disc. And that's just a single point on this single disc. That weight would be spread all the way around the entire periphery of the disc and the interactive surface area.